Hey everyone, I'm Richard. In video 6 we successfully added a name panel that allows players to give their character a custom name. Now in video 7, we're adding player movement controls, allowing you to move your customized character around the screen using your keyboard. First, let's set up the input buttons. Open Project Settings and switch to the Input Map tab. We need to create 4 new actions for movement. Let's add Move Up, Move Down, Move Left, and Move Right. Let's assign keys to each action. I'll use the arrow keys, but if you would rather use the WASD movement controls, you can set those up here. Close the project settings and open the player script to add the movement functionality. First, we'll add some variables to track our movement state. Under the sprites variable, let's add a speed variable with a value of 100, which will control how fast our character moves. We'll also add current movement as a string, which will track whether we're idling or running. Let's set it to idle as default. And current direction as a string, which will track which direction we're facing. Let's set it to down as the default value. The physics process function is the core of our movement system. This function runs every frame and is perfect for handling movement and physics. Inside physics process, let's call update animation, which will handle both our movement and animation logic. Now let's scroll down to add our movement functions. I'll paste in the update animation alongside the get movement and get direction helper functions. You can either pause here and copy the code from the screen, or I'll leave a link in the description below for you to copy paste it easily. The update animation function is where the magic happens. Let me walk through it line by line with an example. Let's say the player is pressing the right arrow key, which means they want to move to the right. The first thing we do is get the input vector using the input.getVector, passing in our 4 movement actions. This gives us a vector 2 that represents which direction the player wants to move. In our example, this will be a vector pointing to the right. Then we'll determine the new movement state by calling getMovement with the input vector. This function takes the input vector and determines whether the character should be idling or running. If the input vector has any length, meaning the player is pressing movement keys, it returns run. Otherwise, it returns idle. Since the player is pressing a key in our example, the vector will have length, so this will return run. We'll also get the new direction by calling getDirection with the input vector. This function determines which direction the character should face based on the input. If the input vector has no length, meaning the player isn't pressing any keys, we'll just return the current direction. This ensures the character keeps facing the same way they did when they stopped moving, which looks much more natural. We need to figure out which direction is dominant. We'll check if the absolute value of x is greater than the absolute value of y. If x is dominant, we're moving more horizontally. So we'll return right if the x is positive, meaning we're moving right, or left if the x is negative, meaning we're moving left. If y is the dominant direction instead, we'll return up if y is negative, or down if y is positive. This logic ensures that when you press diagonal keys, like up and right together, the character will face the direction you're moving more strongly towards, giving us smooth responsive directional movement. Then we'll construct the new animation name by combining the movement and direction, which in our example would be run right. We'll also construct the current animation name the same way, using our stored current movement and current direction variables. If the new animation is different from the current one, we'll update our movement and direction variables to match, and play the new animation using playAnimation function. Finally, we'll set the velocity by multiplying the input vector by our speed. This gives us the actual movement speed in pixels per second. Then we call move and slide to actually move the character based on that velocity. Now let's test everything. If you try moving around with your arrow keys, you should see your character smoothly move in all directions, with animation changing based on which key you're pressing. When you stop pressing your movement keys, the character should return to the idle animation. The animations are playing correctly, but it doesn't really feel like the character is moving due to our plain gray scene color. So let's add a background to make our scene look more complete and make the movement feel more real. Open the main scene and make sure you're in the 2D view. Right-click on the main node and add a new Sprite 2D child, and call it background. Click on the newly created node and move it up in the scene tree, so it renders behind everything. Then in the file system, hover over the background texture and drag it into the Sprite's 2D texture property. Now let's zoom and center the player so we can see everything properly in the scene. Let's hit play. The movement now feels so much better. But let's interact with our panels. When we click buttons, you might notice a small outline appears. indicating that the UI element is being focused. However, when we now use our arrow keys, two things happen. Our character moves as expected, but Godot is also using those same key presses to navigate through the UI. Let's stop debugging. Inside our interface canvas layer, select the margin container. In the inspector panel, under the focus section, set the recursive behavior to disabled. This will prevent Godot from focusing our UI, but our name panel will stop working since it needs to be focusable in order for us to type text inside. So let's enable it just for that one panel. And since we disabled the recursive behavior in the margin container, which is a parent node, we still won't have any conflicts with the directional keys. Now when we run the project again, the focus outline no longer appears. This also means our arrow keys won't navigate the UI when we move our character. And if we try typing our character's name, we are also able to do that without any issues. We've successfully implemented player movement controls that work seamlessly with our character customization system, allowing players to see their customized character in action. In video 8, we'll add save and load functionality, allowing players to save their character creation and load them back later. Thanks for watching, and I'll see you in the next one.